And that is that the opposite of A, or the negative A divided by B, is the same as the opposite of A divided by B, which is the same as A divided by the opposite of B. Now, why is that true? Well, now notice this is a negative. A negative divided by positive is a negative. A positive divided by negative is negative. So really, you can, if you have a negative, you can put it outside the whole fraction. You can include it with the numerator, or you can include it with the denominator, whichever way you prefer. Now you will notice that I normally include it with the numerator. Now that's just a personal preference of the way I normally write the answers. Now it's time for you to practice. I'm going to give you some exercises. If you have trouble with these exercises, you probably need to listen to the tape again or get help. If you're able to do the exercises easily, then you'll find the rest of the tape to be simple. Reduce. The first one, x squared minus 49 divided by x squared minus 6x minus 7. The second one, 2 minus x divided by x squared minus 5x plus 6. Carefully copy down these two problems. Stop the tape, work the problems, and restart the tape to check your answers. The answer to the first one is x plus 7 divided by x plus 1. The answer to the second one is negative 1 divided by x minus 3. If you disagree with either of these two answers, be sure to check with someone. Now let's look at a multiplication problem. Let's start by multiplying the common fraction. Let's multiply 4/9 times 3/8. Well, the way you probably will do that, you'll probably say, well, I can reduce 4/8. You probably say 4 goes into 4 one time, 4 goes into 8 2 times. Then you reduce 3/9. 3 goes into 3 1, 3 goes into 9 3. Now once you reduce, you multiply. Numerator times numerator, denominator times denominator. 1 times 1 is 1. 3 times 2 is 6. So the answer is 1/6. Now for common fractions, I suggest that you continue using this process. For algebraic fractions, it may not work, again, because you do not know your multiplication tables for polynomials. But we can do the common fractions in a way that will also work for algebraic fractions. So let's look at the same example again. Let's look at 4/9 times 3/8. Now what I can do, I can completely factor all numerators and all denominators. I can write 4 as 2 times 2. I can write 9 as 3 times 3. And I can write 8 as 2 times 2 times 2. Now notice that 3 is already factored. Now what I can do is divide out the common factors as long as one is in the numerator and one is in the denominator. I can say 2 goes into 2, 1. 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 3 goes into 3, 1. 3 goes into 3, 1. Notice to divide, you must always divide both numerator and denominator by the same thing. Well, what are we left with? In the numerator, we're left with only 1. 1 times 1 times 1 is 1. In the denominator, we have 1 times 3 times 2. Or 1 times 3 times 1 times 1 times 2, which is 6. So again, we get 1/6. This same process works for algebraic fractions. I'm going to give you another starred concept now that you'll need to know. To multiply algebraic fractions, first of all, you completely factor all numerators and denominators. So the whole key to today's lesson is being able to completely factor. Once you completely factor, then you divide out common factors. You divide out the common factors. And finally, you give the answer. Now to do this, you multiply numerators and you multiply denominators. So you multiply numerators and you multiply denominators. That's how you give your answer. Now you can leave them in factored form. When I say multiply, I simply mean to indicate multiplication. Of course, if you choose to actually do the multiplication, you may do that. It would not be wrong. It's just doing more work than is required. Let's look at an example. Let's multiply x squared plus 2x divided by x squared minus 1 times x cubed minus 1 divided by x squared plus 4x plus 4. Well, what we want to do is to completely factor everything. I need to completely factor x squared plus 2x. The first step in complete factorization is your common factor. We have a common factor of x. So I can write it as x times x plus 2. X goes into x squared x goes into 2x2. X squared minus 1 is the difference of two squares. So it's going to be the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. X cubed minus 1 is the difference of two cubes. The sign in the binomial is the same as the sign in the problem. This is opposite the sign of the binomial. The third one's always positive, so I'll put my signs in first. The cube root of x cubed is x. The cube root of 1 is 1. Now x times x is x squared. X times 1 is 1x. 1 times 1 is 1. Now I need to factor x squared plus 4x plus 4. I need to use guess and check. This tells me my signs were the same. This says they're both positive. The only way to get x squared is x and x. I can get 4 by 2 and 2, and you'll see that we'll check to give the middle term. X times 2 is 2x, plus 2x would give 4x. So now that I've completely factored, the second thing I do is to divide out the common factors. Well, we have an x plus 2 that's common to both numerator and denominator. So I can say x plus 2 goes to x plus 2 one time. x plus 2 goes into x plus 2 one time. So I had the same factor in both the numerator and the denominator, so therefore I divided both numerator and denominator by x plus 2.